You have watched the Interstellar or many sci-fi movie where there is concept called time travel. Even though it's science fiction. Is it possible to time travel in the real world? To understand time travel we need to understand what is time. And I made video about it. Go check it out by clicking that card. Anyway. In short, time is just progression events to past to present to future. It's is almost always one-directional naturally. Now we rewind the time. Can we go back to past using our understanding of physics? Where this thought even came from. Newton physics says time is absolute, it cannot changes, but special theory of relativity changes that says in time is relative to an object's how fast it flows. When object runs fast, time can get slower and slower. By time dilation, which is just this equation, says if an object moves fast then its time gets slower and slower. So if we get the object fast enough, faster than light, that we can time dilatate to negative means go back to past. As it theory seems possible, practically that's impossible. Nothing can go more than the speed of light. Even we made a photon engine spacecraft, we will never reach the absolute speed of light. 'Cause no massive object can reach the speed of light. It's for all massless propagation. So it's practically impossible to even make such spacecraft and theoretically impossible to reach speed of light for massive objects like us. Now let's look at what actually happening in special relativity math. The math says space and time as unified 4-dimension where object can move. The space which are x, y, z where we normally move, and another is time dimension which is ct. Now hear the problem. It's not time, rather c is speed of light and t is time interval. Ct is dimension of length or a space also, but it's theoretical cause it was assumed that an object move at time dimension when it's complete rest. To past to future. Though there is a problem is model. This model talks about something is at absolute rest. But we know that absolute rest is not possible at all. Another problem is this. If we are at the 0 point, we can move this way or another away in space without any problem, but to time, it's not same as that. We only move one direction. The arrow of the time. Even though it's theoretically possible but practically not. Now about the assumption that rest object move to time direction at future but not at past. That doesn't make ct is a dimension, and ct itself doesn't make sense. It's distance that cover by light at time interval t. That much more makes sense. Again, y is where this relationship with of the object that's moving at v velocity. Now if we say that the object's moving at more than c, that's impossible to graph this. Cause light-like is that straight line at 45-degree hyperbolic angle, and this is tan 45 means 1. In hyperbola that means rigidity is infinity. And you can't have more rigidity than that. If you do, then this math completely breaks. Even in Lorentz factor, if you use v over c it gives you infinity, so it's impossible theoretically. Even if we do, then out physics breaks. So this is impossible in both theoretically and practically, but we still have hope. If we use the singularity instead. In this is diagram. Time and space intercept each other. That interception point is singularity. And if we can reach there, then theoretically we can move past the singularity into past. That's theoretically possible. But also that is the point where math again breaks. Because of gravity's inverse distance, our relation at singularity, it comes back to infinity. That doesn't make sense. But we theoretically, though maybe black hole might be that theoretical singularity where we can time travel. Make it into the black hole itself. That's theoretically possible, practically impossible. Caused we can't explore black hole that is light years away. Pull so strong that even lights can't come out. That's why it looks all black. Now to general theory of relativity, spacetime and gravity are related to the time too. Black hole bends the spacetime to singularity and slows time. But that's just a theory. Either black hole actually have singularity or not, we don't know. Either time and space related, that is also question. Spacetime is much a mathematical abstract that is useful to visualize rather than some actually coordination of time. That what we know. And math still comes to singularity, that also means our understanding is not complete. Making assumption is cool, but reality is often different than what we assume. It can be much more boring. Space-time also doesn't say either we have that free will to cross that singularity or it's just math abstract. There is also another paradox that collides the idea of either of this happening. That is the grandfather paradox. It's like if you time travel and kill your grandfather. You would not be born at a first place, then how did you time travel and killed your grandfather? Then there comes theory of multiverses. Distortion is timeline. What we hear in many sci-fi movies. And many comics like DC's Flashpoint paradox. It's a great comics, by the way. Well, anyway, it might seem cool in sci-fi, but it's a friction without proof. So reality can boring instead. Time can be impossible as space-time is just a use math abstract, and there is not real dimension called time. For D, space-time is not real. And time travel is just a cool thought, but our theory just as incomplete.